If you actually look at the copper mining industry, what we're seeing is basically the depletion of near-surface resources. And so we're having to chase mineralisation at much greater depths. And so that drives us to larger scale underground mining. If we just look at OT and we look at what it means to both our company and to the country of Mongolia, it's a pretty substantial prize.
The Oyu Tolgoi mine comprises 4 major deposits. They stretch over 12 kilometres, from Hugo North to the Heruga deposit in the south. The Hugo North deposit is probably one of the greatest copper finds in recent history, producing around 95,000 tonnes of copper ore every day. It's 1,300 metres below surface, 2.5 kilometres long and approximately 300 metres in diameter. 5 shafts and just over 200 kilometres of tunnels will be built to access Hugo North underground mine.
When it gets into full production, which is still, more than 10 years away, it'll be generating 1/3 of the gross domestic product of Mongolia.
I'm proud of taking part in this massive project and taking my own contributions.
Oyu Tolgoi will bring more opportunities to Mongolia, such as taxes and social investments, employment and procurement.
It's an enormous project. It's very valuable to Rio Tinto, but it's also an absolute game changer for the country of Mongolia.
The Oyu Tolgoi mine will use block caving as the mining method. And the reason we use block caving is the only method that can extract very large tonnages of low-grade ore and make that economically viable.
A cave is developed by gaining access to the base of the deposit by a series of shafts and underground tunnels. Then the ore body is undercut to initiate caving, slicing out a continuous layer of rock. This induces stresses into the rock mass, causing it to fragment and break up under its own weight, which creates a muck pile. The fragmented ore is extracted from the muck pile through draw points. These are connected to drawbells, which channel the broken rock into a loader. As the ore is extracted, the support it offers to the cave back is removed and the rock mass starts to break up again. This process creates a cycle of failure and leads to the continuous growth of the cave. Currently, the only way to monitor the flow of the caved ore is to recover markers embedded throughout the ore body before caving commences. These markers move with the ore to the draw points and are picked up by loaders. Mounted to the roof of the tunnels are readers which automatically detect the position of the markers as they exit the cave. This method is limited because the exact path of the ore can't be tracked as it moves around inside the cave. The aim is to model the best route for the caved ore to flow in order to reduce waste and avoid significant loss of value. A better understanding of the flow behaviour will allow us to modify the draw strategy in real time, helping us to achieve the optimum mass flow. The problem is that most signals won't travel through broken rock to locate the position of a marker unless the signal is created by a magnetic field.
Our team in the Copper and Coal Growth and Innovation Group worked together with the CRC, a research group associated with the Queensland University in Brisbane, and with Alexon, a technology developer, to come up with this concept that would allow us to basically track material flow inside a cave.
To prove it, we took CRC underground and they demonstrated that they could see the magnet at least 200 meters away through broken rock, and that gave us the assurance that this technology would actually work.
The way it works is, inside each beacon is a very powerful magnet, and it's spun at a particular speed at particular times every day or every few days. And the beauty of this clever invention is that by having a very powerful magnet, you generate this very strong magnetic field without having to use battery power to go and generate that field. And that field is then detected by other products called detectors. It has a 3-axis magnetometer that's very, very sensitive. And the magnetometer detects that magnetic field that's generated by the beacons, and it can then work out its distance to the beacon. Having a number of these in the cave, it will then be able to allow you to pinpoint where each beacon is. And that allows you to track these beacons in real time, which has never before been possible.
You know, the first really significant deployment of this technology occurred at the Argyle mine. We worked with the Argyle team to basically do a trial of this technology and to prove that it would work before we got ready to deploy it at a much larger scale at Oyu Tolgoi.
For a very complex system, this technology has had very few issues, and I think that speaks to the strength of the development team and the collaboration between all the parties.
I'm hopeful that we will continue doing this in lots of different areas, and we will get to the forefront of underground mining, because ultimately being the best at it is going to has enormous benefits to our company. You know, not only will we be able to operate our new mines in a much more safe and productive manner, but you know, we'll probably be able to do things other companies can't do, and that's a winning.